All right, we've got weak solar activity. We'll take a look at it, and we've gone to the deepest cave we could find. We're broadcasting from the core of the Milky Way galaxy today. We figured maybe the radiation would be beneficial, so we're getting what you'd call a galaxy tan. Here's the sun at 193 angstroms. Active region rising here in the northeast. Check out the massive coronal hole that is the North Pole coronal hole. It's quite well viewed in 193 angstroms. Ionized iron ultraviolet emission spectra. A deep, deep hole. It's a low pressure system on the surface of the sun. Here's a zoomed out version, and check out the coronal holes in the Earth-facing zone. And we'll show you the minor coronal mass ejection. It's one of these, what you'd call a stealth coronal mass ejection, I suppose. Let's take a look at another wavelength. How about 171 angstroms? And we've got 0 sunspots right now, so pretty low levels of solar activity, at least according to the data that we're able to get here at the galactic core from your puny rock orbiting the sun. Fantastic view there, though. That active region is quite picturesque. So here's a star chart. We've got some more solar imagery at the end. But here's a star chart. You can see Jupiter's about to set where we're located right as the sun is rising. Or is that Mercury? It's the moon. All right. There you go. And in Dash the Dash, Sky can animate this for you if you like also. There's a sidebar. You can just bring that down and see you can see what time things will happen and so on. Here's a diagram of the solar system. Oh, happy new moon, folks. Happy new moon. It's 8:08, which I guess is drum machine day. Maybe we'll do a drum solo later. Maybe we'll do a live stream. Who knows? If you're viewing on BitChute, make sure you view us on YouTube. And there we've advanced the solar system 1 week. That's where we expect things to be on the 15th of August. Radio flux pretty flat here over the past couple of days, I think. Current levels 74, is it? 74 solar flux units. And I just pressed refresh there on the Space Weather Enthusiast dashboard. So we saw a little spike in the solar wind speed here, and a dip in the, I forget. It was a dip in the anyway, we'll get to it in a minute. I don't remember which, but there is a signal that just occurred. I think it's a low speed coronal mass ejection that sort of interrupted the coronal hole wind stream that we were seeing before it struck. Anyway, no forecast for any major geomagnetic storms here. And did you hear about Merapi? Mount Merapi is in the volcano news, having produced things like pyroclastic flows. The last time it caused hundreds of deaths in 2010, 347 people killed in 2010. Mount Merapi exploding. Let's take a look at seismicity before we get into more volcanoes. Seismicity just at moderate levels there. There's a bar graph from the past 90 days. And here's the USGS site. No quakes over a 6 magnitude. Some 5 magnitude quakes like this, 5.3 near Prince Edward Islands, rather. The island chain. And this 5.3 at the Solomon Islands. Halfway around the world. It's about an hour and a half apart, by the way, those 5.3 magnitude quakes. Also a 5.1 at the Chile-Bolivia border region. That one is at depth, 137 kilometers estimated depth there. Galapagos Triple Junction saw a 5.0. And that's it. Pretty relaxed for earthquakes over the past 24. VolcanoDiscovery.com is our next stop here, reporting Shivaluch, volcanic ash not identifiable. Don't assume it's not erupting. Mount Merapi. Of course, who's going to go to Shivaluch anyway? There's nobody there. On the Kamchatka Peninsula, we rely on satellite data. Mount Merapi exploding, producing a 12,000-foot ash plume. Please don't pole vault the caldera. Those vault poles are expensive. And so are you. Pavlov producing a 10,000-foot ash plume over the Alaskan Peninsula. So there you go. The aviation level just recently raised over the Alaskan Peninsula and Aleutian Islands. Samisa-Pochnoi also producing a 10,000-foot ash plume. Great Sitkin in the Aleutian Islands. Incandescence of the active lava domes blocks showing up late yesterday. Fuego, 14,000-foot ash plume as it explodes. That's a Guatemalan volcano, by the way. Nevado del Ruiz in Colombia. Volcanic ash dissipated in Summit, dispersed in Summit webcam. Revenador exploding in Ecuador, 15,000-foot ash plume there. 27,000-foot ash plume over Peru as Sabancaya explodes. Continuous ash emissions from there. And Novato State Chilean exploding, 13,000-foot ash plume, intermittent puffs. Please don't pole vault the caldera. Please do visit our links at smAsho if you think it's the same. It's not. Next, looking at the sun suite of instruments, the suite instruments that face the sun on the GOES 16, like the X-ray flux, to see no major flares, just one B-class flare over the past 3 days of note. No spikes in the proton flux, no coronal mass ejections of note either. No major flares, no major proton events, no sunspots. Weak solar activity, only a 74 solar flux units on the radio flux. There's our GOES magnetometer over the past 3 days. Fairly smooth here. And Earth remains in a South Pole current sheet, where it will be until further notice. So here we're looking at the polarity of the heliospheric current sheet, and this red area is the South Pole oriented. The poles orient the material in the current sheet. This material is South Pole oriented, and this material is North Pole oriented. And Earth is going to remain in the South Pole current sheet here, probably through tomorrow's daily space weather video as well. It may look like the Earth will end up in the North Pole current sheet by tomorrow, but I assure you, darling, that it's unlikely for Earth to snap across before 24 hours. So anyway, can't really tell you how we forecast that. It's too much to get into on the daily space weather video. Here's another view of the same data here. The line of sight field plot. And if you're a new viewer, congratulations on finding our channel. The data comes from Stereo A's magnetometer, Stereo B's magnetometer, and 51 ground-based magnetometers. The National Sunspot Observatory. It's really important data. Next, the line of sight coronal hole plot, and you can see North Pole coronal holes looking like they're rotating in there in the northeast, ahead of that active region. South Pole coronal holes rotating out. So a little bit of field progression there. Keep in mind this data is 8 hours old already when we shot the video, and this isn't even streamed live. It's not streamed live, and it's not streamed live. Likelihood of large flares is quite low with no sunspots. No surprises to our regular viewers there. KP index currently at 1. And this is the coronal hole wind stream subsiding. The KP index is a measurement of global geomagnetism from a number of ground-based stations. So here's this little coronal mass ejection. Looking at the real-time solar wind here. And since it's Sunday, we'll do a little demonstration. If you're not familiar with this page, the real-time solar wind is now slightly more interactive than it's been. you can select a small area just by doing this, and it will actually zoom in on that area for you. So this little tutorial here, this page can be a little bit finicky depending on what sort of browser you're using and so on. So there's this little coronal mass ejection, and you can see this mild little spike here in the density accompanied by a dip in the solar wind velocity and an increase. So it was a hot, slow coronal mass ejection. I mean, there's the data. Anyway, let's get off this custom zoom and go back to the 1 day. And there you go, we've zoomed back out. You can see that weak coronal hole wind stream. It did get a little fast there. There was a moment when it made it up to nearly 500 kilometers per second. But just over a very brief period. So pretty weak coronal hole wind stream there. The density only made it up to like 20 protons per cubic centimeter. Here's 4 hours of magnetosphere movie. And we've got fairly homogeneous pressure according to the space weather modeling framework. Keep in mind, folks, this is a model, not a direct measurement, as we can't measure that much stuff at that large at distances. You're looking at like 12 Earth diameters there. Anyway, there's 4 hours of data, magnetohydrodynamic pressure. And somebody who takes the pressure off of us a little bit and helps us out a lot are our patrons. And while we've got massive changes coming in September, we don't plan a full phase out until New Year's Eve. So thanks to our patrons. Please consider becoming a patron at patreon.com/smashamash. It's the true source of funding for the content. Also, make sure you visit our other links. smashamash.com. We've been making all kinds of changes. You can link to the forum and the merch shops as well if you want to pick up some merch. Thanks again to our patrons who get all kinds of early alerts and background information and science data nobody else gets to see. Here's our other geospace magnetosphere movie. It's 4 hours of ground magnetic perturbations. Giving you insight into things like the location of the geomagnetic pole and the magnetic pole and so on. Anyway, fairly homogeneous as far as Earth's B field in the past 4 hours. Next, thanks to all of our viewers on YouTube. If you're new to the channel, please don't forget to press like and subscribe. As again, we are broadcasting from the galactic core here at the Smash News Network, least busted name in news. And it's not really hot. I'm starting to feel strangely. It could be from too much radiation. I just don't know. Anyway, press like and subscribe. Tell your friends and foes about the channel. Congratulations on realizing it exists. Why it was so hard for us to get you to realize it exists, I have no idea. Another little public service message. Seriously, I don't. I just don't. So, and that's part of the reason why we're broadcasting from the galactic core, because we thought that maybe this would be considered safe enough for you to not be scared and spooked while watching our. We endeavor to have our viewers not scared and spooked, which is one of the many countless reasons why that. We're also on BitChute. There's an exclusive coming soon in the pipeline. Shout out to Black Pill Radio. Yes, Black Pill Radio. Today's cosmology segment's integrated into the daily space weather video. Check our other cosmology segments at youtube.com/smashamash/playlists. There's like 215 videos or something like that in the cosmology segments playlist. Here's apod.nasa.gov's astronomy picture of the day. It's a Perseid. See that there? That little bright spot? Yeah, that's a Perseid. It's traveling at like 6 kilometers per second. 60 kilometers per second. That's pretty fast. Count to 10. That's 600 kilometers. That's pretty quick. Planets are big. We try to shrink it down to help you out. By the way, if you think smashamash.com/forum looks the same, you've obviously never been there. Check it out. We put in some summer colors here to round out the end of summer. You might have thought it's the same. It's not. smAshomash.com. Also, check us out on Instagram if you haven't. And check out our stellar athlete from the U.S., the U.S. cycling team, Jennifer Valente. Congratulations on the Olympic gold in the track cycling Omnium, the 4-event series. Probably the hardest track event. Probably the most sought after. Congrats on that one. That's not easy. We're going to pick a random number today. It's 973. And why would we do such a thing? Because of the Neil Gorell Swift Observatory. It coincides with something. And the something is XB 2129 plus 470, the low mass X-ray binary. So here's this X-ray source. You're looking at hard X-rays. It's what this observatory measures. And you can see there's the 16-year chart. It's pretty consistent X-ray source. Fairly weak. And an inhabitant of the Milky Way galaxy, most likely here. Obviously, it's probably a Milky Way galaxy resident. And there's the 30-day chart of its outputs. If you want to go look at this yourself, just head to the Neil Gorell Swift Observatory, go to entry number 973, and then click on Simbad. See that little link there? Right there where my pointer is. Simbad. Click on that. And that'll bring you to this page. And then if you click on All CDS, it'll take you to the CDS portal, and then you can look at it in all kinds of wavelengths. So here's this particular low mass X-ray binary. That little point of light there is indeed an X-ray source. The real question is it a gamma ray source? Does it create a bright spot on the Fermi? And there's a triangle there. So for all of you folks who are frightened of shapes, let's make that full screen. Oh my God, there's a gamma ray triangle. Which means, I don't know what that means, but it's very scary. So here it is in X-ray. Oh, check it out. It's got a very funky X-ray signature here. We've got a brighter X-ray source here, and then a dimmer X-ray source here. That's your low mass X-ray binary showing up in full vivid color. And you don't always see that, but in this case you certainly do. Here it is on the Galix. This is UV light. And it's quite dim in UV light. And those are not empty spots. Those are probably a lack of data spots because it's not going to be that unhomogeneous. Well, maybe it is. They could be jets, but in any case, this particular low mass X-ray binary, not bright. In that, and going down the scale here, let's go to optical. There are bands Z and G. Yes, I can read letters off of a screen. There it is in optical. And Pan-STARRS is quite a high-resolution survey. No, don't worry, it's not the Eye of Sauron. And lastly, let's go into infrared. There's the heat signature. The infrared light emissions from that low mass X-ray binary. Oh, what do you know? In the constellation Cygnus, V1727 Cygni. So there you go, also known as XB2129 plus 470. You can look it and your favorite objects up yourself at the Neil Gorell. Neil Gorell was very interested in explosions. Explosions in space. Hopefully none of these stars will explode. By the way, notice the time frame. We don't know what year it is. We're hoping that you're getting this video not in the year 2047. There's a time warp happening. I don't know what it is. It must be because of the orbits of these blue supergiant stars and Sagittarius A star and the spaghettification of, oh my God, the whole thing is getting spaghettified. Oh my God, spaghettification. And that's today's cosmology segment. Let's go back to the Earth environs. No charging hazards for satellites. Here's the X-ray flux over the past year from Solon.info. Here's the 3-day chart of the electron flux. And as we forecasted, the electron flux cratered during the coronal hole wind stream. Our regular viewers wouldn't have been surprised by that. Warning levels were thwarted by solar plasma. And you can see this massive dip. The forecast was way off by NOAA and right on by us. Expecting a little increase here. I would expect a bigger increase as well in the coming days. I'm going to put a purple mark right about there. We'll follow up in 2 days and see if I was right. Here's a diagram of the Van Allen belts, just showing you distances in miles and so on. The location of the International Space Station just inside the inner Van Allen belt and so on. This image here, this imagery shows you the entire air column in terms of electron density. And I'll let it play through a second time here. It gives you an idea of where GPS errors are most likely to occur, which is typically around the equator at noon. And there are other zoomed in views of this, by the way, if you want to look at total electron content for your location. We only show the planetary scale one. Here's a diagram of the atmosphere showing electromagnetic radiation penetration, temperature of the thermosphere, density of molecular material, such as oxygen, nitrogen, and so on, ozone, and so on. And here's the ionosphere. So this is your ionosphere map, vibrational frequency, showing some anomalies once again here. And these are anomalies from the 30-day mean. And we've put up a second graphic here to show you what I mean. Let's actually show the latest image first. There is the latest image from 10:15 Universal Time. Things looking fairly normal there. And here's the 30-day anomaly. The 30-day, the anomaly in megahertz from the 30-day mean or median. And you can see some, mostly once again, anomalies are centered on the South Atlantic anomaly, which I seriously think we should rename this the South American anomaly. It's like way over here now, no longer over the Atlantic Ocean. Anyway, here's the latest image that is from 10:15 Universal Time, and as I said, it's fairly normal at that moment. By the way, we're going to do a meteorology segment. It's a separate video if you haven't seen it. We haven't recorded it yet or streamed it live. It'll be on twitch.tv/smAsho before it ever appears anyplace else. All right, and let's do bonus features. First, the El Teide Spain hydrogen alpha imagery. The ground-based solar observatory located in Spain, showing us 0 sunspots. Some prominences around the south and the northeast. Likelihood of anything major happening is quite low. Here's the GO 16 SUVI imagery. And we could see some flaring. In fact, we do see some pink here. That is flaring, by the way. So there is a little bit of an increase in the X-ray flux there from that active region. And active regions can produce flares. We don't need sunspots to produce flares. We don't need sunspots or flares to produce coronal mass ejections. But we're not warning or watching for anything like that. It doesn't look like an environment that'll produce any. Here's your intensitygram. We've pressed refresh to show you 0 sunspots. Here's a colorized magnetogram, I think. And we've got additional imagery for you. And there's a colorized magnetogram. And here are some close-ups of the northeasterly active region. This is 304 angstroms ionized helium. One of the crowd favorites, and I don't blame you. And here's 171 angstroms. Thanks for tuning in to the Daily Space Weather. And may that solar wind be at your back.